So far you've seen substitutions where the substitution is a linear substitution. So for example, that helps us integrate something like sine of 3x plus 5. And we've also seen a substitution where the derivative of the substitution cancels to make it simple. So here we know that the derivative of tan x is sec squared x. So if we let u be tan squared x, then when we divide by the derivative, we're going to cancel the sec squared x. In this section, we're going to look at slightly more complicated substitutions. So let's have a look at this example and see why it's not as simple as that example that we just did. So they've given us the substitution to use here. They want us to use u equals 2x plus 5. So if we use that substitution, let's leave x as it is. We're going to have the square root of u dx. So we want to replace dx with something to do with du. So let's work out du by dx. Du by dx is equal to 2. So that tells us that dx, if we rearrange this to get dx as subject, is a half du. So let's replace x with a half du. And at this point, I'm actually going to take the half out of the integral. We might as well do that. We can factor out a factor of a half. And then we're going to have inside the integral x root u du. Now, this looks like a problem because we haven't managed to eliminate x. And we can't have a mixture of x and u. Remember, for substitution, we're trying to eliminate all the x's and get us an integral just in terms of u. But actually, this isn't the problem because we can eliminate x and get it in terms of u because we have an equation for u. We know that u is equal to 2x plus 5. So if we rearrange this, we can get an expression for x in terms of u. We would know that x is equal to u minus 5 over 2. So all we can do is we can substitute that into our integral. So we're going to have a half integral of u minus 5 over 2 multiplied by, and then I don't really like square root of u when I'm integrating. I prefer u to the power of a half. So let's replace square root of u with u to the power of a half because they're equivalent. And then I'm going to multiply out the numerator inside this integral. So I'm going to have u to the power of 1, because really I've got a bracket there on the numerator. You could write it like that even if you wanted to. So we've got u to the power of 1 times u to the power of a half, which is u to the power of 3 over 2, and minus 5 times u to the power of a half, which is minus 5 u to the power of a half, and on the denominator we're going to have 2. Okay, so at this point we've got an integral that we can do. You could take out a factor of a half outside of this integral, or you could split this up into a half u to the power of 3 over 2 minus 5 over 2 u to the power of a half. I've just divided both terms by, or if you prefer to think about it, I've split it up into two fractions like that. So let's leave the half out at the front, and then we can integrate each of these terms separately. So we're going to increase the power of u by 1. So that's going to be 5 over 2. And then we're going to do a half divided by the new power, which gives us 1/5. And then here we're going to do increase the power by 1. So u to the power of 3 over 2. And then we're going to do minus 5 over 2 divided by 3 over 2, which gives us minus 5 over 3. And then finally we can multiply out this square bracket because we've got a half in front of the integral. So that's going to be 1/10 u to the power of 5 over 2 and minus 5 over 6 u to the 3 over 2 and plus c for our constant integration. And then our final step would be to get this in terms of x, remembering that u is 2x plus 5. In part B, we're asked to do exactly the same integral, but using a different substitution. So this time it's worth noting that u is going to be equal to the square root of 2x plus 5. So this time we're going to do the integral of x, and then the square root of 2x plus 5 is just u. So our first job is to replace dx with something to do with du. So we need to differentiate this. I'm going to differentiate it implicitly. So to do this implicitly, I'm going to differentiate the left-hand side with respect to x. So firstly, we differentiate it with respect to u, which is 2u, and then we times by du by dx. And if we differentiate the right-hand side with respect to x, we get 2. An alternative way of getting du by dx would be to differentiate this expression here. So if we differentiate the left-hand side with respect to x, we get du by dx. And I guess we could probably write this as 2x plus 5 to the power of a half. And then if we did the chain rule, we would times by the power and reduce the power by 1. But then we'd have to times by the derivative of the inside function, which is 2. So du by dx, a half times 2 is 1, so we'd get 2x plus 5 to the minus a half. But we'd get exactly the same answer as before, because this is du by dx equals, now we could write that as 1 over the square root of 2x plus 5. But the square root of 2x plus 5 is just u, so this is 1 over u. And this is exactly the same as we got before with implicit differentiation, because we could divide through by 2, and then we'd divide through by u to get du by dx equals 1 over u. So either way, using the fact that du by dx is equal to 1 over u, we can rearrange this to get dx is equal to u du. So that means that our integral can be written as x, u, and then we replace dx with u du. Or we could write that as x u squared du. Now again, this is a problem because we haven't managed to eliminate x, but what we can do is we can rearrange our substitution to make x the subject. So we know that u squared minus 5 over 2 is equal to x if we rearrange our substitution. So let's sub that in. So we've got u squared minus 5 over 2 times u squared du. And then again, we can multiply out the numerator. We can think about it like that. So on the top, we're going to have u to the power of 4 minus 5u squared over 2. And now we've got an integral which is just in terms of u, and we can split this up into a half u to the power of 4 minus 5 over 2 u squared. And then we can just do polynomial integration. So we're going to increase the power of u by 1 to u to the power of 5, and then divide by the new power. So we're going to have a half divided by 5, which is a tenth. And then same here, we're going to increase the power of u by 1, and then we're going to divide by the new power. So minus 5 over 2 divided by 3 gives us minus 5 over 6, and then plus our constant of integration. And then finally, we need to get this back in terms of x, and actually I think the easiest way of doing this would be to use this equation here. We know that u is equal to 2x plus 5 to the power of a half. So we can write this as a tenth, 2x plus 5 to the power of a half, and we're doing all of that because that's u to the power of 5, and then minus 5 over 6, 2x plus 5 to the power of a half, that's u, and we're doing u to the power of 3. And then finally, we can simplify this by using the power laws. We're going to do 5 times by a half to get 5 over 2, and then minus 5 over 6, 2 times by a half to get 3 over 2 as that power. and we get the same answer as before.